Let's take a look at this next example. A sheriff saw that 676 drivers were screened and 6 were arrested for driving while intoxicated. Based on those results, we can estimate that P of I equals 0.0088, where I denotes the event of selecting a driver who is intoxicated. So when we look at P of I, they're telling us that means the probability of somebody being intoxicated is 0.00888, according to this statement here. So now they're going to ask us they're asking for, in the final part, what does P with a little I and a bar on it say? Well, let's see. P with I and a bar on it. First of all, the bar means the reverse of whatever I says. Well, I says that they're intoxicated. So sticking a bar on it means the opposite, meaning not intoxicated. Well, if the probability of somebody being intoxicated is 0.00888, the probability of not being intoxicated is everybody else, the rest of the probabilities. Well, remember, probabilities have to add up to 1 or 100%, so I can subtract the probability I have for intoxicated from 1, and that will give me everything else, the probability of people not being intoxicated. So the question is, what is 1 minus the 0.00888, and that gets you 0.99112. Sorry, there was one more 8. So 0.99112. And that's your final answer for the probability of somebody not being intoxicated. The next few examples talk about a deck of cards, so let's talk about what we know about a deck of cards. First of all, what do we know about cards? Well, there's a total of how many cards in a deck? Well, there's a total of 52 cards. We also have our cards are broken up between suits. There are the hearts and diamonds. And then there are clubs and spades. Not the greatest artist. Remember, the hearts and diamonds are both red cards, and the clubs and spades are both black cards. And also, there are face cards, which have literal faces on them. The king, queens, and jacks are all face cards. The number cards are the 2, 3, 4, 5, 6, 7, 8, and 9, and 10. And then you do also have aces, but they're considered kind of their own separate thing. So the next thing you might want to also find out is how many cards are in each suit. Well, if there's a total of 52 cards divided by there are 4 suits, that will tell you that there are 13 cards in each suit. That will help you out quite a bit too. If you need to and you're not really familiar with cards, remember you are allowed 1 sheet of handwritten notes, one-sided on each test. So this may be something that you include on your 1 sheet of notes if you're worried about forgetting. So that might be something that you want to do. It's all up to you. Let's take a look at A. On A, we're looking at the probability of drawing a diamond. Well, first of all, then we need to know how many diamonds there are in a deck of cards. Well, in a deck of cards, how many diamonds are there? Well, we said there's 13 cards in each suit, so that would be 13. Out of a total of, how many cards did we say were in a total deck of cards? We said 52. So that'd be 13 divided by 52, which ends up being 0.025. And we're going to leave it as a fraction that's unreduced and as a decimal. Unless they actually ask you to reduce your fractions, I wouldn't bother. Here's another one. Find the probability of, they have the word diamond written out, but this time they have a slash on top of it, which means we're looking for the complement or the opposite. So it means we're looking for something that is not a diamond. Well, if 0.25 or 25% are diamonds, it means the other 1 minus 0.25, the complement, which is 0.75 or 75%, are not diamonds. Let's take a look at the next one in C. In C, we've got find the probability of drawing a king, or, and I cannot skip that word, that's really important, or a heart. So remember, or means that we're going to add some probabilities together. So let's start out with, first of all, what's the probability of drawing, let's say, a king was first. Well, first of all, there's 1 king in each suit, times there are 4 suits. So that means that there's a total of 4 kings in every suit. So that means there's 4 kings total in an entire deck out of a total of 52 cards. So that's how we're going to start, is by finding the probability for just the kings. Remember, the or meant that we were going to add. Now we have to find the probability for the hearts. Well, let's take a look at the hearts here. Well, how many hearts are there in a deck? Well, that is a suit. We said there's 13 cards in each suit, so we'll do 13 out of, just like before, how many cards total were there? 52. Now, the only problem when you're doing the or the adding is you have to be careful. There may have been a card that was counted twice, so we need to subtract anything that got counted twice. Well, there was one card that got counted twice, and it's the card that fits in both categories. That's a king. It's the card that's a king and a heart. Well, that means we're looking at the king of hearts. There's only one of those in a deck of cards. So we'll have one of those in a deck of cards out of your 52 cards. So we counted up all the kings. That was a 4 out of 52. Then we counted up all the hearts, 13 out of 52. But then we noticed, hey, the king of hearts got counted as a king and a heart, so it got counted twice. That's why we subtracted one of the extra copies. And that leaves us with, well, how do you add and subtract fractions? Well, luckily we have a common denominator already, so we can leave that the same, and then we're just going to add or subtract normally by going straight across the top. So we'll do the 4 plus 13, which is 17, minus 1 is 16. And again, I know that can be reduced. We're not really worried about it. What we're going to instead do is just convert it into a decimal. So 16 divided by 52 is 0.308. So that's your probability of drawing a card that is either a king or a heart.